ACCESS-NRI main team. The first one is around a tool called Benchcap that has been released recently, that is to do the scientific evaluation of cables. And this poster is presented by Sean Bryan, and it will go through the current capabilities of the tool and the features that are currently in development. And this is the poster number 4. The second poster is the poster number 5, and it's presented by myself, and is to go through changes that we're proposing for the common management of cable. And this poster will go through the major ways that those changes are going to impact cable developers, and also explain what benefits we expect from doing these changes. So we've chosen to highlight these 2 projects as posters because they impact all cable developers and to some extent cable users. So if you're part of the cable community, please come to our posters, you won't regret it.
Thank you.
Next one is still me.
Still there.
In the Agent for the Land Modeling Working Group, and that I co-chair with Ian Harman and Anna Nicola. And so we currently have 24 members registered on the ACCESS-NRI forum for the land group. And we meet first and third Tuesdays of the month. During our meetings, we discuss ways to collaborate, because the land working group is not around one model. It includes everyone who's working on ACCESS modeling in Australia. And one thing, if you can't make the meeting time and you would like to participate, contact one of us co-chairs via the forum or any way you want. That will be good to know. And lastly, we have a workshop today, this week, Tuesday, Thursday and Friday. And at this workshop, we want to continue our discussion for organizing our collaborations between all the members of the working group. And we also want to discuss how we're going to organize ourselves to use a land allocation scheme, and we'll provide land targeted training. Thank you.
Okay. Thanks, Claire. Next, we have Aidan Hedergen on building software better with SPAC.
Right. Here's the Lego model. On the PC1 to find the PC1 and then fit together. It's sort of a pain. But when imagine you trying to build a model, you don't know where the pieces are, the instructions are barely legible, and yeah, and it's really frustrating. That's what building scientific software can be like. Right? We've all been there. You go, this should work. Why doesn't it work? Well, what we're going to try and do, well, that didn't go very well, did it? Yeah, anyway, don't worry. So what we're going to try and do is use SPAC to make model building easier, better, and more transparent, more reproducible, and just better in every possible way. So come to my poster, build a model, take a picture, upload it to the forum topic, and you get to come up with a box of Lego.
Next, we have Alex Hipp on Globus, moving the Earth for Australia.
Right, I'm here to talk about Globus, which is a suite of tools for dealing with massive data sets. For those who don't know, ACCESS, Australia's research and education network provider, we carry all your data around. So ACCESS has been working on behalf of the sector to establish a whole of Australia Globus subscription offering. Both ACCESS and Globus are not-for-profit entities serving the research sector. Many significant Earth systems projects worldwide have been using Globus to move large quantities of data around since 1997. And many Australian institutions and compute facilities are already subscribed. We're looking to establish an Australian Globus community of practice over coming months. So we'd like to get everyone involved in that we can. Come and have a look at post number 15 in the foyer just out there. And if you need to move large amounts of data around, or you want to look at distributed workflow orchestration, come and talk to your institution or run it.
So localized and skillful weather forecasts for coming months is valuable. For example, for agriculture, we can got $1 billion extra gains per year. So our calendar seasonal cloud forecasting model like ACCESS-NRI can capture the larger scale climate pattern pretty well, but in order for overshoots even after calibration. So we developed a deep learning model to downscale from 60 kilometers to 5 kilometers. The model learned from a lot of ensemble forecasts as well as 5 kilometer AWAP data. So we can see we try to generate a more realistic daily perception. For example, in panel 4, we can see, different from the previous model, we can generate a rainfall, have a special classes. Looks more similar, much more similar to the AWAP strategy.
Yeah, my name's Owen. I just recently started as a research software engineer at NRI, and with a speciality in visualization. So I made a poster talking into it because I just wanted to highlight that we are starting to ramp up a visualization service and what that'll mean. And if you come and have a look at the poster, there's some more details about that, but I've got a few ideas, and to start with, we're sort of just collecting examples of visualizations and working on a few projects to do some sort of nice 3D renderings and create some movies. I'm putting some of that stuff as we go up on a Vimeo channel, which is vimeo.com/ACCESS-NRI, one word. But yeah, it's more details on the poster, and it's all early days, but yeah, so the main reason is just to highlight that I exist, and if you've got any ideas about visualization projects or want to talk about these topics, then yeah, thank you.
Just basically introducing what we're doing with ACCESS-OM3. So this is the successor to ACCESS-OM2 that many of you will be aware of. So it's an ocean and sea ice model. I've got 2 slides up there in one. Somebody want it. Okay, so ACCESS-OM3, it's we're upgrading the ocean model from MOM 5 to MOM 6, so to take advantage of all the advantages that we saw in Bob's talk earlier today. The sea ice is being upgraded to size 6. That includes a flow size distribution, and we're also adding WaveWatch 3. And so WaveWatch 3 will make waves which crash into the ice, which will break it up into small pieces, which we can represent with flow size distribution. And it also uses a different architecture. It uses the Yorpsy coupler we heard about just a moment ago. So we've got a whole lot of plans. We've made quite a lot of progress, and if you want to learn about what's coming over the horizon, come and talk to me in the poster.
Oh, good.
Great. Take it away.
Hi everyone. Customer didn't happen overnight. Going back, for me, like 14 years ago, we had a really small, just a few of us meeting every week, and snowballed, keyword, into more than 60 people showing up for weekly meetings. And so for me, the NRI is all about growing the other working groups. And I think a good strategy is to copy others' ideas and make them your own. 2 things about Cosima that really worked for me, I think, are we make it really easy for ECRs to do science, really lower the bar of entry, and we importantly give them platforms to feed back their efforts for a lasting legacy. Back to snowballs briefly. I grew up in Canada, and the funnest thing you could do in winter after a snowstorm, and I kind of think of the NRI as like a big snowfall. Go outside and make your, I'll tell the truth. The funnest thing you could do is go outside and make your own little snowball and then throw it into someone else's face. But that game always ended badly. The second funnest thing you could do is get a few friends together and gather some snow and push and gather and push. And as soon as you made a big enough snowball, other kids would come around and you'd make like a monster snowball, like up to the roof, so weird. And then spring would come, and the snow would melt, and like the fields would be full of grass, and there'd just be this like couple giant snowballs just lasting out there for months.
Thank you. Next is Paul Leopardi on improving the reusability of ACCESS model input data.
Yeah, g'day. So this is a relatively new topic. It's recently been recognised by people at NCI and ACCESS-NRI and elsewhere that a lot of the data that's used by models is data that's produced interim by models through the fact that a model is a workflow. So you have your input data, which is source data, but you also have these ancillary data files which are produced in the middle of the model, which aren't indexed aren't really, given a decent confidence, nobody can find them unless you're actually in the project itself. So I have a poster, poster number 21 is upstairs, so come have a look and I'll have a more chat about it later.
Hi, I'm Unpa from the Bureau of Meteorology, and here I'd like to draw your attention to our study led by ACCESS-NRI at Monash University on the multi-week prediction and attribution of the Black Saturday heatwave event in southeastern Australia. As you may remember, this heat extreme event that occurred in late January to early February of year 2009 resulted in hundreds of human casualties and great economic losses in Victoria. So in this study, we showed that this heatwave event was related to moderate La Nina condition, which provided it relatively long lead time predictability, and its record-breaking extremity was well predicted by the Bureau's ACCESS-1 forecast system, and about 10% of the anomalous heat was attributable to the anthropogenic forcing, increasing since the beginning of the 20th century. Thank you.
Group update.
Thanks. Hello everyone, I'm Lucy McCormack. I'm an Archie Follower at Monash University, and along with Ben Gold and Benzie, co-chairing the Pricing on the group. So we're a new group, quite small, growing. Paul showed beautifully earlier that we're starting to get critical mass. But we have a few big tasks ahead of us, and the first one is providing advice on an approach to coupling and mashing on into ACCESS. And that's where we need your input. So we are open to advice. If you have any good advice, both on community-related issues and also coupling, please get in touch via the High Forum or come and speak to me. We also meet every 6 weeks on Wednesdays, although I suspect that will be changed as we start to engage more in the international community.
Thanks. So over the last year, a group of 12 of us from Customer developed this high resolution, this is a MOM6 SIS2 config. And so you can see this is just a small region of the Antarctic coast zoomed in. You can see on the left, this is the 1/10 degree version. We used to work from ACCESS-0201 thinking that 1/10 degree does a pretty good job around Antarctica. You can see, if you really look close to the Antarctic coastline on the right there in the 1/40th degree, there's so much of the EV activity in the Antarctic slope current that we're really not getting at 1/10 degree. So we've just finished 10 years of this simulation now, thanks to a nice one-off grant from NCI. And we're just starting to analyse the science. So Christina has some preliminary science on co-coaster, so check that out.
Great.
So we know that global climate models are quite expensive to run. They also do not resolve subgroup scale dynamics. So we can use machine learning, data-driven models to emulate some of these physics. So the problem is that most of our GCMs are typically written in Fortran, and machine learning models are done pretty much in Python. So we came up with a new Python Fortran bridge, which is called TorchStream, which helps us to integrate machine learning models into GCMs. And we tested this by replacing the physics options in Chem4, typically radiation and image physics. And we do see good results. So if you want to learn more about this, please come and see my poster, which is number 30. Thank you.
As we all know, the Antarctic glacier is melting, and in addition to raising global sea levels, this can also have important impacts on climate. We've heard today from Paul and from Felicity, the ice sheet isn't included in coupled models. Okay, and so this is showing this schematic. We have a cross section of Antarctica, and at the top we've got the real world, where we have our ice sheet, which is a big reservoir of fresh water. But our coupled model representation on the bottom doesn't include this big reservoir of fresh water. And this means that over the 21st century, when the ice sheet melt is accelerating, the coupled models aren't representing this extra fresh water entering the Southern Ocean. Now this is important because this fresh water increases the stratification of the Southern Ocean, and this changes the distribution of heat. So this is going to have important impacts to global climate. But we don't have a good understanding of exactly how important these impacts will be, because the studies that have looked at this have done so using different models and adding different amounts of fresh water in different ways.
So in the Southern Ocean Freshwater Release Model Experiments Initiative, also here, we propose a standardised Southern Ocean freshwater forcing protocol to quantify the impact of missing Antarctic meltwater on climate simulations across multiple models.
Okay, thanks very much.
Hi, I'm Kim Reid. I'm one of the co-chairs of the Forecasting and Prediction Working Group, along with Debbie Hudson and Nathan Eisenberg. We're a very new group, and we're a bit of the half of the group in that we let everyone join us. So we're forecasting and prediction, but we're also machine learning, data assimilation. Anyone who doesn't have a home can join us. We've had one kickoff meeting and one presentation on the machine learning infrastructure needs, and we also have a workshop on Thursday on machine learning for modelling and prediction. We have a proposed experiment with the ESM group on running ACCESS-NRI for 2019 to 2023, which obviously covers a lot of extreme events that happen over Australia, with random atmospheric initial conditions and prescribed observed ocean ops, in order to assess some of the atmospheric forces on the triple La Nina, such as whether summer fires caused the La Nina or how Tonga affected the weather. We have an upcoming meeting on data assimilation infrastructure needs and using single column model. Sign up and follow our Hive announcement thread for announcements. And if you don't know what those words mean, talk to Aidan after meeting.
Okay, then on to your talk.
Okay, in the research chat. If we knew that it was going to be anomalous rainfall 3 weeks in advance, that would be incredibly useful for a wide range of stakeholders. However, rainfall is pretty badly forecast beyond a few days, let alone at weekly timescales. However, the larger scale weather systems are forecast a lot better, including the horizontal water vapor transport, and horizontal water vapor transport is also highly correlated with rainfall. So at sort of 3 to 4 week scales, there are some locations and seasons where if you actually just use the water vapor transport instead of the rainfall, you get higher forecast verification skills. And we think this is due to uncertainties being caused by the parameterization schemes. So it comes to my person for more on ACCESS-S.
Right, thanks, Kelly.
I'm Doogie with ACCESS-NRI. My poster is about the ACCESS-NRI intake catalogue. Some of you would have seen this in the training session on Monday. It's a way to help people discover and load data, access and access-related data from within a Python environment on Guardi. It's easy to add your data so that other people can find it, and it is available now in public content environments, so it's hopefully quite easy to use.
Next is Mike, interactive monitoring and diagnostics analysis of live access models.
Hi everyone, I'm Mike. I work alongside Doogie, and as an extension to the intake catalog he's talking about, we've built the beginnings of a diagnostic analysis tool that will run live as your model is running on Guardi, with an intent to try and tap into the outputs that are produced as the model is running to produce visualizations that are helpful to diagnose whether the model is on track or things are blowing up. This is a brand new kind of framework that we're doing now, so it's kind of fairly young in its development cycle, but we are moving towards more sophisticated visualizations with Owen's help and integrating metrics so you can do some calculations on your model outputs as they move along. So yeah, come and see us if you'd like to know a bit more.
Quick quiz. So I've got two different patterns of sea surface temperature. And on the right, different precipitation responses of some sort. And I was just wondering if anyone had any guesses of which sea surface temperature would pair with which precipitation. Just shout out if you have any ideas. So, yeah, I didn't hear, but I think that's probably right. But anyway, so what we're trying to look at is how spatial patterns in long-term sea surface temperature trends affect things like precipitation. So the left are the trends into artificial sea surface temperature sets used of ESM 1.5, and right are the resulting digital precipitation trends, which are quite different. And so plot by the posted for more details on those experiments.
Right.
Hi everyone, I'm Yimam from the University of Melbourne. I'm the co-chair of the ACCESS working group together with Charmaine Franklin and Matt Woodhouse. We also have our ACCESS-NRI Lisa and Heidi. Our working group was established back in May, and so far we have 39 members, and we've been running meeting monthly. So since May we've had 4 meetings, so you can find out many minutes on forum. Our next meeting will be on the 19th of October. If your work is related to X-ray robotic, you're most welcome to join us. So on Thursday this week, we will be running a working group workshop where we've organized a number of really interesting talks as well as a discussion session where we're going to discuss what the community needs in terms of documentation, training, evaluation tools and data sets, and new feature infrastructure as well. And we'll be running an ACCESS 200 training in the afternoon, so people will get some hands-on experience in running our ACCESS regional model for real. So I'll see some of you there.
Hi everyone, I'm Lee from Bureau of Meteorology. So today I would like to introduce you to ACCESS-NRI, which is a tool to assess how climate change alters the magnitude and also spatial pattern and potentially climate process in a certain event. So we explore the event in Bureau's subseasonal to seasonal forecast model, ACCESS-S2. And for example, this is how black summer will look like in real forecast. So if we modify the initial condition by reducing the greenhouse gas levels at the initialization and also remove the mainstay changes associated, we can represent this event in a past climate after a very short spin-up. And this is how this event will look like in a past climate. By comparing these two forecasts, we can say that almost the whole Australia region will be, it was hotter than it might have been in the past climate, and also within 1.3 degrees, normally forecast in Australia, 0.8 degrees is attributable to climate change. So if you would like to hear more information, please come to my post. Thanks.